as the information about the schedule was intimated earlier, the first session we will have a presentation by an eminent expert, Professor J.K. Garg, on a theme, remote sensing and GIS in environmental management. To introduce you to Professor Garg, he is Professor and Dean in University School of Environmental Management in Guru Gobind Singh, Indraprastha University. Sir, we welcome you to the studios.
Thank you.
To give you a brief background about our eminent expert, Professor Garg. Professor Garg has got his education and his training from the premier institutions in the country. He has done his MSc from the Institute of Advanced Studies, Meerut University, MPhil from Jawaharlal Nehru University at New Delhi, and his PhD on wetland conservation and management from Gujarat University. And thereafter, he has worked in the premier institutions and prominent amongst them being ISRO, Indian Research Space Organization, where he has done some very pioneering work regarding the use of space applications in the management of environment. His current interests are how to assess the natural hazards and how to manage the situations and provide ready-made data on very vast systems which are not practically possible if we like to do it on the land. So by the use of these technologies, Professor Garg has developed techniques, and he helps people who want to pursue in these areas. And it is noteworthy to mention that he is the first person who helped Ministry of Environment and Forest to prepare the inventory of wetlands in our country. So we are very honored to have you, sir, with us. And a request to the students, while Professor Garg makes his presentation, so let us hear to him and concentrate on the presentation. Professor Garg, I request you to please make the presentation.
Thank you, Dr. Sokhi. Dear students and colleagues, today we shall discuss about the utility of remote sensing and geographical information system, particularly for environment management. As you are aware that we have so many environmental issues in our country, but the major among them are basically ecosystem degradation and loss, wetland biodiversity conservation, desertification, environmental impact of various developmental activities, various hazards, pollution of various types like water, land and air, and many issues concerning our coastal areas, besides global environmental issues like greenhouse gases and global warming. Before I begin, it will be pertinent to know what remote sensing is all about, though the time is limited, but we can imagine a situation. Suppose you are sitting on the ground or standing on the ground, then you are seeing a limited area. But if you go to the top of your house, then you start seeing much more area, and if you climb a tower, then you see much more area, and you start seeing patterns between the landscape elements. So similarly, if you go to the aircraft and later on to the spacecraft, if some sensors are there, then we can see larger areas, their interrelationships, and certain things which otherwise we cannot see. So basically, remote sensing is the science of obtaining information about an object, area or phenomena through the analysis of data acquired by a device not in physical contact with that particular feature under investigation. Basically, we use satellite and aerial imagery for studying various environmental issues in the country or elsewhere. Briefly, if we can see that like our signature, suppose there are so many people, we have different signatures. Likewise, in remote sensing also, we make use of the differing signatures of various objects like vegetation, water, soil, wet sand, and so many other features which differ basically because they emit, they reflect and absorb different amount of energy from the sun or from some other sources, and this gives us different or varying signatures, though there may be sometimes confusion, but nevertheless most of the information which we acquire through remote sensing is really very accurate, maybe sometimes more than 95%. Now, as far as sensors are concerned, to acquire this information, basically we have three types of system. One about which you are familiar is your cameras. Camera can acquire on the film. Now of course digital cameras have come, and that is another way of recording the information. That is also remote sensing, but that is basically ground remote sensing. And similarly, if you go to the aircraft or to the spacecraft, we can digitally record. There are various mechanisms to record the information. Sometimes we use scanners and sometimes we use linear arrays. But at this point, it may not be pertinent to know that how that information is acquired, but what I shall be concentrating mainly, how this satellite data can be effectively used for environmental conservation and management. Before I go further, we have to remember four types of resolutions. That is very important if we are studying environment. Spatial resolution, which refers to what size of element we can resolve. Depending on our problem, we can choose the satellite sensor. Nowadays, satellite data is available from more than a kilometer resolution to sub-meter resolution. So first we have to define our problem, and then we have to select and use the data. Similarly, what wavelengths, what spectral region of the light, solar light or some other this light we have to use. And another resolution is the kind of or the degree of detail we want, and for that we use the term radiometric resolution. And there is another term which is known as temporal resolution, which refers to at what repetitivity we want to observe a particular phenomena or we want to acquire some information. For example, if we are studying flood or if we are studying cyclone, maybe hourly information is important or daily information is important. But if we are studying, let us say, forest type, then even seasonal information may be sufficient. Now, if we see as far as capability of India is concerned, as many of you may be aware that India is among the topmost country in the world which have sensors operating in various spectral regions of the country, having various spatial resolution and temporal resolution as well as radiometric resolution. Now what our image you are seeing is that the sensors what we have, 1 kilometer resolution, 360 meter resolution and 188 meter resolution. If we use 1 kilometer resolution, such sensors or such data is normally used for climate change studies. And if we use 360 meter resolution data, then at regional level and where mapping is required to be done at 1:250,000 scale, meaning that 1 centimeter on our map is equivalent to 25 kilometer on the ground. Similarly, we have sensors which have 188 meter resolution, so that can also be utilized for regional studies, especially for fishery forecasting, etc. Then we have satellite with better resolutions like 23 meter, 5.8 meter in black and white and color, and we have now better than 1 meter spatial resolution data. This data can be used at a local level for mapping of 1:2000 scale or 4000 scale, basically a very small area. If you want to see that, you can see in the images also. I can show you some of the images, some of the features which you were not seeing earlier are now starting seen if we use 23 meter resolution data or 5.8 meter resolution data or 1 meter resolution data. Now these are some of the images where we can see the details, whatever is there in 23.5 meter resolution data. This is IRS list 3 data, Indian remote sensing satellite list 3 data. Then 5.8 meter pan means black and white data, and if we merge the two, then we get little more information about the features. This particular image is from Jawaharlal Nehru Stadium, what you are seeing in New Delhi. And depending on the resolution, the size of the resolution, we can see more and more details in this. So this is our list 4 data, where in multispectral modes means we have more than one spectral bands and then they are combined for generating a composite, which we normally call in remote sensing false color composite, because the colors what we are seeing here, red, is not the true color. Basically this color is of vegetation, and vegetation normally in false color composite we give the color red. So, and these small buildings, you start seeing, that is how the detail becomes more and more apparent. But this kind of information may not be always required. It may not be needed repetitively every day, but this kind of information will be required for local area planning, or let us say urban planning kind of studies. So after seeing these images, basically we conclude that in general, remote sensing and GIS can be utilized for various environmental issues which I have talked about earlier. Again, you can have a look at the slide, that for ecosystem inventory and monitoring, environmental assessment of developmental activities, biodiversity assessment, etc., environmental zoning, environmental hazard donation, etc. There are various methods to elicit this information or drive this information. We can use visual techniques where when we don't have the computers to analyze the data. So what we can do is that we can obtain some photographic product, and these products are available from National Remote Sensing Agency at Hyderabad. Now this National Remote Sensing Agency is known as National Remote Sensing Center, and they can make you available this photographic product as well as satellite data depending on the problem which we want to analyze and study and monitor. So in this regard, we have to make some maps, analyze the data repetitively depending on our requirement. Similarly, we may use digital analysis. Some of may will have access to the computers, and specialized software is required for analysis of this data. Commercially it is available. Some of the softwares like ERDAS, ArcGIS, etc. are required for analysis of this data, and these are various techniques. So I am not going into the details of these techniques, but we'll see the applications of this. Likewise, Geographical Information System or GIS is a computerized system for storage, retrieval and analysis of data about the landscape or the Earth's environment. So in this you can have various sources of data which can be combined to generate models for various environmental issues, whether somebody is interested in conservation of coastal areas, mangroves, or water quality, or some watershed conservation. So we have to use certain models in this environment, in GIS environment, and we can come out with solutions which otherwise are not possible generally without this technology. In fact, now GIS is being used in various sectors, not only for natural resource and environment management, but even in hospital management, traffic movement, and so many other things, and even in crime detection. So now we shall see some of the applications in different sectors of environment. Forests are our main resources in the country, which cover about 23% of the area as far as India is concerned. But we have a very low per capita availability of forest, which is about 0.1 hectare. Actually, our forest is in various stages of density. The closed forest means which is good forest is only about 12% in the country, which is a very serious situation. And as per our policy guidelines, we have to make it up to 33%. And in this regard also, this remote sensing and GIS will help us identify those sites where we can do afforestation or reforestation or plantation. Now I'll show you some of the images. On the image you see various red colors. Actually, as I have said, that red represents vegetation, and different shades of red what you are seeing, what you have seen in the earlier image refers to various types of vegetation. In this particular case it was forest types. So based on this information we can delineate various forest types, their density. This particular image what you are seeing on your screens pertain to Chamoli Joshimath area in Uttarakhand, where using remote sensing it is possible to delineate and map the extent of pine forest, oak forest, and some mixed forest, Devdar forest, and various other types of forest also, which are in different stages of degradation, and depending on their altitude also you can do the zonation. And if one is interested in knowing their density, that also can be obtained from the satellite data. What is required is that you have to calibrate it by going to the field you go to the field and correlate with the spectral information or the tone seen on the image, and it can be more than 60% density, more than 40% density, or maybe more than 20 or less than 20. So depending on your requirement, you can probably map the forest. Otherwise, if you use the FAO classification, where more than 40% density refers to dense forest, and between 10 to 40 is our open forest, and less than 10 is our degraded forest. So this technology is very useful for mapping various forest types, its density, and even to assess the optimal resource use which should be there in some watershed or in some forest area or in some state. What we can do is that we can identify different forest type, and if we go to the field, depending on our field information, we can find out what is the annual increment. And normally we should not extract more than 30% of the annual increment in our resources or the tree growth or the foliage growth. Otherwise we will not be using the resources sustainably. Another area where remote sensing has found a great use, remote sensing GIS, pertains to conservation and management of protected areas. This particular example, what you are seeing on your screen, pertains to Nanda Devi Biosphere Reserve, which is among 14 biosphere reserves in the country, and it's very important. And remote sensing data has been used, as perhaps you can see on your screen, to identify vegetation types and what are the changes which have taken place, and subsequently we can use this information to assess habitat suitability, because as you may be aware that musk deer is the animal which is endangered species, is found in this area, and we can with the help of certain models identify those areas where currently this musk deer is you can say roaming or having its habitat, and we can identify newer habitats where these animals can be located. So basically what it means is that remote sensing and GIS we can use to identify even those habitats where relocation of the animals can be done which are in a state of danger. So another area where remote sensing has played a key role in our country is inventory and management of wetland resources. It may be interesting to know that India is among the pioneering countries in the world where remote sensing has been used for inventory and conservation of wetlands in the country. Basically, remote sensing provides information and inputs on wetland occurrence, wetland inventory which can be done type wise, seasonal changes in the water spread, areas under aquatic vegetation, structural components of wetlands and habitat diversity, wetland degradation, turbidity, and surrounding vegetation, vegetative cover and land use, which is very important for conservation and management of wetlands, as you people may be aware. So these are some of the images which have been used for inventorying of the wetlands in the country. What you can see, some types of wetlands are shown here, lakes are there, high altitude wetlands are there, then oxbow lakes which are from meandering rivers or those rivers which go in the plains, then some waterlogged areas are there, and likewise reservoirs and so many other types of wetlands are there. In the coastal areas also, whether they are mangroves or coral reefs, so all these things can be identified and monitored using satellite remote sensing. So this particular image where on your left side you see coral reefs, they can be easily seen and mapped. So basically what you find is that remote sensing has tremendous use as far as wetland inventory and mapping is concerned. You may be interested in knowing that India is going for its second inventory, and a digital database of all the wetlands in the country will be available on 1:50,000 scales, means all the wetlands which are larger than 2.25 hectare, its registry will be available to the individuals, to the people for wetland conservation and management. So about 5.8 million or 7.8 million hectare area is there in the country, which does not include paddy and rivers and canals, etc. So basically if we include this area and this smaller wetlands, then wetland area excluding paddy is about 12 million hectare in the country. So this particular map shows that disposition of various wetlands in the landscape. This map is from Gujarat, and this area shows that how many wetlands are there. This particular image or this particular slide shows you that what is the number of wetlands in the country and the area covered by each wetland, the image of which you have seen earlier. So this is for coastal wetlands, and the total number of wetlands are about 27,000, and the area occupied by them is 7.58 million hectare, which are bigger than 50 hectares in this particular inventory. Once this inventory is available, this information can be stored, retrieved and analyzed in the GIS or geographical information system. So information system can be developed where at the click of your mouse you can get information about particular type of wetlands, where a particular wetland is located, what was its area during post-monsoon season or pre-monsoon season, for what purpose it is being used, or what could be another purpose. Another major area where remote sensing can be utilized is in biodiversity conservation, and which has acquired importance after Rio Summit of 1992. So remote sensing help us study of biodiversity at landscape level, at ecosystem level, and even at species level. So I don't want to go into the details of what are the threats. You people may be aware that the loss is because of habitat destruction and loss, alteration in ecosystem composition, introduction of exotic species, etc. And besides, global climate change. Remote sensing can be used, as I have said earlier, for direct mapping of species, habitat mapping, and establishment of direct relationship between spectral values and species distribution pattern. So this is this example I am showing you for conservation of biodiversity in wetlands. Through remote sensing data, we can get information on the wetland structure components, habitat types, species classification data can be obtained from the field data. This can be combined, and we can predict biodiversity or of that particular wetland. So these are some of the examples where remote sensing data can be used, and very effectively for study of wetland degradation. Its structural components are, actually I don't want to go into the details. Structural component refers to open water, some turbidity, aquatic vegetation which may be submerged or emergent, or that type of information, and its land use of the catchment. You should always remember that no conservation of wetland is possible without taking effective measures in its catchment, because catchment is the place through which there is always exchange of matter and energy between the wetland and its surroundings. So this is very interesting example which you may appreciate, that this particular example or lake exists in Manipur. The name of this lake is Loktak. It is the largest freshwater lake in the northeast part of the country. It has floating biomass which is known as fumdis, and on these fumdi mats, dancing deer or sanguine deer, which they call locally, or Cervus LD thrives, and this is the only habitat of this animal available in the world. The remote sensing has been used to study this lake, and you can see in the left top images that there are ring-shaped structures on which people even live. They do fish culture and sometimes even paddy. And there are about 5,000 people living on such places, and they are known as fumdis. Remote sensing can be used to study their number because the number should not increase beyond the critical limits. And as you can see that in 1989 and February 1999, there is more than 6 times increase in the number of fumdis, which is beyond the critical limits or sustainable limit of this. So remote sensing can also be used for action plan preparation, and I don't want to go into the detail, but it is possible to identify that which are the areas which need conservation for, let us say in this case, Deeperbill, which is in the Guwahati city, that which are the areas which are where water holding capacity should be increased and where no action is required, or where removal of aquatic vegetation or dredging is needed. So remote sensing and GIS have come a long way in addressing the problem of natural resources survey and management. Another area where remote sensing and GIS have been used and can be used are basically for environmental impact assessment. And we have certain remote sensing amenable indicators where which can be used very effectively and very critically also in preparation of environmental impact assessment statements or EMPs for that matter. And these pertain to specifically for mining, power generation and river valley projects, delineation of active and abandoned mines, land use land cover changes, degradation of forest, mine spoils and areas affected by dust from mines, water pollution grossly. If it is a colored water pollution, then remote sensing data can also be utilized to locate it and its extent, widening and shallowing of rivers and streams, coal mine fires, areas affected by fly ash, and environmental hazards like landslides and degraded watersheds. Due to paucity of time, I may not be able to go into the details, but you can see that in a particular case in Korba, where more than 5,000 megawatt of power is generated, remote sensing data has been utilized to identify the areas which are getting fumigated by power generation as well as deposition of fly ash, and a map can be generated which is there on your right side, which indicates that which are the areas which are more polluted or less polluted. So similarly for if you see this, then we can identify this mine spoils, forest types, ash ponds, etc., and if there is a spillover from these ash ponds. Now you see in this river, if you can see that on the right corner of your image, that there is a black strip, and that black strip is due to effluents which are coming from a nearby river into the Brahmani river, which is passing through Talcher. And we can observe this colored, you can say, plume 32 kilometers downstream. Remote sensing data can effectively be used to identify even the sampling stations.
So I also have a question, like we are hearing every day, because this current problem of floods in Bihar, the Kosi river is changing track. So is it possible with remote sensing technology that we keep a track and keep on informing people that well, it is coming here, be prepared, something like that? I think Dr. Shukla also had this in mind.
Actually, if you use multi-date satellite data, so Kosi river, in fact, we have studied earlier, not now, but this is a migratory river. It keeps on changing its course every now and then, and if you look at the imagery, then the different courses of Kosi can be seen. Now the current, and there are so many courses of the Kosi, and this flood is there, but sometimes again we may face the problem if there is a breach in the embankments, and it may take altogether different river course. So actually there are not only two courses of Kosi, but there are many courses, and we should take measures in controlling the floods by strengthening those areas also, so that floods don't take place at those places.
Yeah, very right. So there are tremendous possibilities.